Hi guys. So guys, in this video, we'll be implementing one amazing project called Automatic Traffic Safety. So this is going to be one computer vision related project. So here we'll be performing something called object detection. So let me tell you about the project, what we are gonna develop here. See, I think you already know in some of the country, they use automatic traffic management system. That means what happens actually, beside the roads, they will be attaching actually lots of CCTV camera. And that CCTV camera will actually keep on tracking, let's say, road activity. That means whether a person is wearing helmet or not during riding the bikes. Okay, if they're not wearing, so what this system will do, it will automatically extract the let's say license plate number. That means the license plate information, and based on that actually they will fine the money, okay, to that rider. So these kinds of system actually most of the countries use nowadays. So here we'll be implementing similar kinds of actually system. So here we'll be implementing similar kinds of system. That means what I will do here, I will use some real-time custom data. With that, I'll be training one, let's say, object detection model, and that model will be able to detect whether any person is wearing helmet or not during riding the bike. Even it will also let's say detect what kinds of, let's say, vehicle they are riding, whether it's a, let's say, bikes, whether it's a car. Okay, so these kinds of actually vehicle also it will try to detect. Even it will also try to detect the license plate. Got it? So this is the system actually we'll be developing. So if you are completely new to this computer vision field, and if you don't know about object detection, no need to worry. In my YouTube channel, I already created lots of content related object detection. You can watch those recording. You will get the entire idea. So what we'll do, guys, let me first of all show you the dataset from where actually I'll be using the dataset and how this dataset looks like. So guys, if you don't have the custom data, so what you can do, you can use one amazing actually platform called Roboflow Universe. So let me show you Roboflow Universe. So this is the actually product of Roboflow. So I think you already know about Roboflow. Roboflow is a computer vision platform. So here you can perform all kinds of computer vision related tasks. So it is having one product called Roboflow Universe. So Roboflow Universe is having all kinds of computer vision related data, whether it can be object detection, classification, segmentation, key point detection. Okay, all kinds of data it is having. Now let's say you want to perform object detection and you want actually data. So what you can do, you can filter out this object detection. Even you can also search here. Let's say what kinds of data you need. Let's say I need let's say helmet. Okay, anything, just search here. Helmet, vehicle detection. Then you can also search about, let's say, then you can also search about road safety detection. Okay, these kinds of actually search keyword you can search. Now you will see different data set would be there. Okay, now what I will do, guys, I'll be using one data set from the Roboflow Universe. So this is the data, guys, called helmet computer vision project. Okay, this is the data name. So I'll give the link in the description. From there you can download the data. Now if you want to use this data, guys, what you have to do, simply you need to click on the download project. And again, I'm telling you guys, if you're using Roboflow Universe data, you don't need to annotate these other data. This data is already annotated. This is the best advantage here. Now let's say you don't have the annotated data. So what you have to do, you have to manually annotate those data, and it is like very time taking task. And how to perform the annotation with the help of Roboflow platform, I already created one tutorial in my YouTube channel. You can go ahead and watch that. So guys, now if I show you the data, it is having actually three classes called helmet, license plate, and motorcycle list. Okay, now if I show you the image, so this data is already annotated as I already told you. So let's open up one image here. Now you can see they have annotated the motorcycle, the entire vehicle. Even they have also annotated this helmet. Okay, even they have also annotated this license plate. That means three kinds of label we are having in this data. Okay, and I think this is enough for me if I want to perform this kinds of automatic traffic management system, traffic let's say safety system. Now if you want to use this data, just simply click on the download project. Now you can see one option called download dataset. Okay, now if I click here, now it will suggest me different format. Now here I'll be using YOLOv3 object detection model. So I'll be selecting this YOLOv3 PyTorch. Okay, this is the format. Now either you can download this data as a zip file, either you can download as a source code. Okay, let me show you the source code. So this is the code actually it will suggest. You just need to copy and execute from your notebook. It will automatically download the dataset. So for you, what I have done, guys, I have created one notebook. You can see this is the notebook I have created. So now let me connect this notebook, and all the resources would be available in the resources section, in the description section. From there you can download and you can use it. And make sure, guys, you have selected runtime as a GPU. So here you can see I have selected runtime GPU. Okay, so now let me connect. So guys, as you can see, my notebook is connected. Now the first thing what you have to do, guys, you have to clone the YOLOv3 repository. So this is the YOLOv3 repository. Let me show you. In my YouTube channel, I already created the tutorial related YOLOv3, how we can use YOLOv3 for the object detection task. You can check it out. So you can see this is the GitHub of the official YOLOv5. Okay, and with that we can perform the object detection task. So simply what I will do, I'll just try to clone this repository. So let me clone. Then after that you have to install the requirements. So it will have one requirements file. Let me show you. So requirement.txt file it is having, and inside the requirements you are having all the package. Okay, so these are the requirements you have to install if you want to use YOLOv5. Now let me install all of them. Now see, if I refresh, see YOLOv5 has been cloned. Now I have to install these requirements. Okay, now for this you have to execute this cell. Now let me execute the cell. So it will install all the requirements. After that it will show you the version of some of the package. Okay, that's it. Okay, so execution is completed. Now the next thing, guys, what I will do, I will install Roboflow. Okay, Roboflow, because here I'm going to use Roboflow universe to get the data. So for this I need to install Roboflow. So let me install Roboflow. Okay, fine. Now simply what you need to do, just copy the link, copy this code snippet and try to replace here. Okay, now let's execute. See, it will automatically download the data here. So see, guys, my dataset is downloaded. You can see inside helmet folder, training, testing, validation. Okay. See, all the data have been downloaded. Now if I show you the YAML file, so here you are having 3 classes. Okay, as I already told you. Now you can also open up the image. You can also see. So let me open some of the image. Let's say this is the image. Now if I show you my project working directory, so I'm inside YOLOv5 folder right now. And if I show you my data location, so this is the data location. Okay, so make sure you are inside YOLOv5 folder. Okay, because YOLOv5 folder will be my root folder. And now if you want to see the data.yaml file, you can execute the cat command. So it will show you the entire data.yaml file. Okay, what is the content inside that? Now I have to load this data.yaml file and I have to extract the number of classes. I think, remember, it is having 1 NC classes. Okay, here that means 3. So this thing I have to extract. So for this I'll be executing this code. Now I'll see number of classes would be 3. Okay, now here what I have to do, I have to use one configuration, that means model configuration. So here we'll be using YOLOv5s model. So it is available inside YOLOv5 models. Now you can see YOLOv5s. Okay, so this model actually will be using. You can also use L model, X model. Okay, M model, it's up to you. S model means this is the smallest model. Okay, you can also use any other model, it's up to you. Whatever model you are using, with respect to that you have to select this YAML file, and it is having all the configuration related to the model. Okay, now see, I have to change this NC parameter because I'm having only 3 number of classes, but it is having 80 classes because it is a pre-trained model. Okay, it's a pre-trained model on the Coco dataset, and Coco is having 80 classes. Okay, that's why what you have to do, we have to replace this number. So how to replace the number? So this is the content of this YAML file. You can see. Now if you want to change it, you have to execute this line of code, and whatever content you can see in the YAML file, I just copy pasted here, and only I'm just changing this NC parameter. Now see, if I execute, so it will automatically write that file in the model again. Now see, if I show you, now see, this is the file it has created, custom YOLOvs.yaml, and now you can see NC parameter has been changed. Okay, now we'll be using this configuration. Now simply you can start the training. To start the training, what you can do, guys, you can execute this command. So there is a train.py file, you can see. Let me show you inside YOLOv5 folder, train.py. You have to execute train.py. Give these are the, let's say, parameter, image size, batch size, number of epoch you want to train. So let's say as of now I want to train 100 epoch. You can also increase the epoch size as per your requirement. If you want to get a good model, you can increase the epoch size. Here I've given 100 because I want to show you only, that's why. Now pass the data location, so it will automatically pick up the data location. Okay, so from the data.yaml file, because you can see data.yaml file contains the data location. If I show you, this YAML file contains the data location. Okay, like where your image is present. You can see inside test folder image is present, inside train folder image is present. Okay, it will show you the entire image location. Now you have to give the model configuration. The configuration we have created, I think, remember this configuration path I am giving. Then I'm also giving the model name I want to use. I want to use YOLOv5 s.pt model. This model would be automatically downloaded from the internet. Then this should be the output folder. Okay, that means inside that folder all the artifacts would be saved. Now see, if I start the training, if you're using YOLOv5, it's very easy to use. So guys, as you can see, my training has started. It has loaded my data. Now see, epochs is running. So you can see. So my epochs is running. So what I will do, I'll pause the video. Once this training is completed, I will come back. So guys, as you can see, my training is completed and it has saved all the artifacts inside a runs folder. Inside runs folder, it has created one folder. Let me show you. So inside runs folder, it has created one train folder. Inside that, the folder name I have given, YOLOv5 result. Inside that, you'll see your weight. Okay, this is going to be your weight, guys. Now let's download this weight because I'm going to create one web application. And for this, I need this weight. So let me download this weight. Make sure you're downloading base.pt. Okay, this is your trained model. Now you can see it has also saved some of the artifacts like your validation loss, your complete results it has saved. Okay, now if you want to visualize them, what you can do, you can execute this line of code. So see, my model has downloaded. Now let me, now see, it is having one result.png inside that folder. I'm just rendering it. Let me show you. So this is the complete like evaluation metrics actually will be getting. See, this is your losses. That means as per your epochs is increasing, loss is also decreasing. And this is your MAP score. That means mean average precision. And epochs is increasing. Your accuracy is all increasing. That means your learning is better here. Okay. Model is learning good. Now what I can do, I can show you some batch images. So these are some batch images you can see. Okay. So these are some batch images. Now let me show you some augmented ground truth as well. See, YOLOv5 internally, automatically it will perform the augmentation. Okay, you can see some of the augmentation technique it has applied. Okay, different augmentation it has applied. Now, if you want to test on top of your test data, so simply give the test data location. So this is my test data. Inside image, I'm having all the test image. I'll just copy the path. And here I'll just try to mention source is equal to your test images path. That's it. Now simply execute this line. So there is another file called detect.py. So inside detect.py, all the code they have already written, like how it will load the model, how it will detect, everything they have written. Okay, all you just need to execute and make sure you are giving your model location. You can see this is my model location base.pt. Now if I execute, it will perform detection on top of all the images and it will save the results. Okay, in the runs folder again. So let me show you. Okay, done. Now if I open the detect folder experiment, inside that you will see all the results have been saved and this is the detection, guys. Okay, see, that's how we are getting the detection. Helmet, motorcycle as well as the license plate. Amazing, guys. Although I trained only 100 epoch, but detection is pretty good. Now what I can do, I can also show you the detection with the help of this code. It will automatically take all the image and it will render, okay, on the Colab notebook. So see, this is my rendered results. Okay, now what I will do, guys, I'll just try to create one web application. That means user will upload one image and they will get the detection. And I will also tell you how you can open up your web camera. That means, let's say if you want to detect as a live camera, you can also do it. So for this, what you have to do, you have to clone one repository. So this is the repository, guys. I'll give this repository link in the resources section. Even I will also add in the notebook. Let me add it here. So here I think I can add. Okay, this is the repository. I'll add in a text. Okay, so this is the repository. Okay, so make sure you are cloning the repository. So let me clone the repository. I'll copy the link, open the folder, and let me clone here. So git clone my repository link. So guys, you can see cloning is completed. Now I'll go inside the folder. I'll just write cd. That means change directory. YOLOv5 app. Okay, now I'm inside this folder. Now let me open up this one. Now see here, just try to remove this YOLOv5 folder. Okay, because I'm going to clone newly because this is my old one. Now I have to clone newly. So what I have to do, you have to, I think, remember. So there is one link. Actually, there is one command actually I had written. So copy the command and just try to execute from the terminal. Okay, completed. Now let me open up my VS Code here. Now inside YOLOv5 folder, you have to move your model. The model actually you have downloaded. So let me move it. I'll just cut it from here and I will keep it here. Okay, this is my model. Now let me show you. So I already created the template. That means the web template. So here I'm using Flask for this. You can see I'm using Flask. Okay, Flask. With the help of Flask, actually, I have created this template. Now just open the app.py file. So here I have already written all the route. So only you just need to change here the model. I think model name is fine, base.pt. Okay, no need to change anything. Everything is fine. Everything is fine. So what I will do, I'll open the template file, index file. Okay, inside that I'm going to change the project title. So guys, as you can see, this is the project title. Now here I'm going to change the project title, or I can write automatic traffic safety. So yeah, everything is fine. Now simply what I will do, I will install the requirements. See, all the requirements you have to install. So for this, open up your terminal, and first of all you have to create one environment. So to create the environment, just write this command conda create -n, give the name of the environment. Let's say I will give traffic. You can give any name. Then python is equal to, let's take 3.10 -y. Now let's execute. See, it will create the virtual environment. After that, we'll be installing the requirements. So environment is created. Now let's activate. This is the command to activate the environment. Now I'm going to install the requirements. So just write pip install -r requirement.txt. So let's wait. Once installation is complete, I will come back. So guys, as you can see, installation is completed, but I will tell you one best practice actually you can perform. See, here we have newly cloned this YOLOv5 repository now. So inside that, see, inside YOLOv5, let me show you. Inside YOLOv5, you have another requirement.txt file. Okay, just try to open it up. And whatever package actually you can see here, just try to copy. Okay, try to copy all the package and open up my requirement.txt. So the app actually you have cloned from my repository. See, this is the requirements. Now what you have to do, see, from here, from base actually, just try to select everything and delete and try to mention here. Okay, that's it. Now let me save and let me again install the requirements, because this is the old requirement I was using. Some of the error actually you might get, that's why I'm installing the new one. Okay, that's the thing. Okay, so execution is completed. Now let's launch our application. So let me launch our application, guys. So I'll just write python app.py. Now let's give the allow permission. Then I will open up my browser and search for localhost 8080. Okay, now you can see this is the front end of our application. Now here you can upload the image. So let's upload one traffic image and click on the predict button. You'll see that you will get the detection after some times. So here I'm getting one error, guys, called proxy path on your system. So guys, if you're facing that error, what you have to do in the detect.py, let me show you. In the detect.py, you have to add this code snippet. Okay, if you're getting that proxy path issue, you have to add this code snippet. After that, just try to save. And now let's execute our application. So now I'll come back. Now it's running. Now let's upload the image and do the prediction. Okay, now see guys, here I got the detections. It is detecting the motorcycle helmet as well as the license plate. Okay, and now if you want to open the live camera, what you have to do, just give /live here. Okay, /live here and press enter. It will automatically open up your live camera. Okay, so all the functionality I have already written in the code. Let me show you in the app.py. So here I have given another route called /live. So it will open up your live camera. You can see source is equal to 0 I have given. Okay, so as of now, I'm not going to open up my camera. But if you want to open up your camera, you can do it. Okay, and the complete code actually I will share with you. You can execute the same code as it is. Okay, so yes guys, that's how actually we can perform this automatic traffic safety detection. Hello everyone, welcome to this video. In this video, I'm going to discuss about how we can perform object detection on top of our custom data with the help of YOLOv5. If you don't know, YOLOv5 is an state-of-the-art object detection model. So with the help of this particular YOLOv5, we will be learning how we can perform object detection on top of the custom dataset. So in this particular video, I'm going to discuss each and every component of this particular YOLOv5, like how we can set up this particular YOLOv5, how we can prepare our custom data, and on top of this custom data, how we can efficiently utilize this particular YOLOv5 model, and how we can do the custom training operation. So after the training, I will also show you how we can inference on top of our custom data. Even I will also show you the live prediction with the help of web camera. So this is going to be completely end-to-end discussion. So make sure you are watching this particular video till the end. And I hope at the end of the video, you'll be learning each and everything about object detection with the help of YOLOv5. So instead of talking too much, let's start with our agenda. So first of all, let me write down all the agenda actually I'll be covering in this particular video. Then I'll be starting with our implementation. So at the very first, I'm going to discuss about YOLO V5. Okay, but exactly this YOLOv V5, I will also show you the official GitHub repo of this particular YOLOv V5. Okay, then after that I'll be showing you how we can set up YOLOv V5. Then we'll be learning about how to prepare training data. Then after that, we'll be learning about custom annotation. So what is annotation? I'll discuss each and everything, because whenever you are performing any kinds of object detection task, first of all, you have to perform the data annotation. That means you want to generate a label of your image, and that particular label with respect to the image actually you will be giving to the model. Your model will be learning about the object. So that is why actually custom annotation is very much required. And here I'm going to discuss about some of the open source tool you can use, okay, for the annotation purpose. Then fifth, I'm going to show you how to configure YOLO model. Then I will also show you how we can start the training. After training, we'll be discussing about the evaluation. Then we'll see that the test inference. Then at the last, I will also show you the live object detection part. Detection with webcam. And here I'm going to use single image prediction. Single image prediction. And at the last, I will also show you how we can create a web application. Okay, web application. So we'll be creating one web app so that if someone is using your application, and they'll be doing this kinds of object detection task. So yes guys, this is the agenda for this particular video. And now I'm going to discuss each and every component in detail. So make sure you are watching this particular video till the end. So first of all, let's try to see about YOLOv V5. So if you want to know about YOLOv V5, so you can search on Google YOLOv V5. Okay, YOLOv V5. So that is the official GitHub actually will get of the YOLOv V5. So YOLOv V5 is nothing but it's a state of the art object detection algorithm. So it is having lots of variant. If I show you the model view, as you can see, it is having lots of pre-trained model variant. So it is having YOLOv V5 N model. That means this is the nano model. It is having another model called YOLOv V5 S model. This is the smallest model. M means this is the medium model. L means this is the large model, and so on. Okay. If you check this particular model, this size is increasing as well as the parameter size is also increasing. Now you have to choose the model with respect to your task. Let's say you want to create an application and that will predict real time. So you don't want to get any kinds of lagging during prediction. So at that time you can go with lighter model. That means the smaller model, because it is having lesser parameter. So there actually will get like very fast speed. But whenever you are worrying about the accuracy, you are not worrying about the speed. At that time, you can go with bigger model. Let's say you are working in the medical domain, their accuracy matters a lot instead of the time. So that time actually you can use bigger model. So with respect to your task, actually you have to select the model. But in this particular video, I'm going to use this particular model called YOLOv V5 S model. So here the problem statement I'm going to solve with the help of this particular model, it can be easily solved. I'll discuss about the problem statement. Even I will also show you the dataset, which dataset actually I'm going to use in this particular video. But here you can use any kinds of dataset. I'll show you the dataset hub as well, like where you will get the dataset. All kinds of dataset actually you can download and you can perform the object detection on top of it. So yes guys, this is the brief introduction of the YOLOv V5, and you can also see the benchmark of this particular YOLOv V5. So it is having lots of version actually, YOLOv V5, then YOLOv V6, V7, V8. Currently actually V9 also came in the market. So YOLOv V5 is a pretty good model. You can see the benchmark. So it is having different variant, as I already told you. So here you can see the COCO AP score. That means the average position score with respect to all the model variant. and as well as their speed, okay, on top of this particular GPU. So guys, here you can see the benchmark table. So you can see the different model variant actually they have trained, and they have collected the API score as well as the faster speed, okay, on the GPU. So you can see all the model like YOLOv5, N model, S model, M model, okay, all the model performance you can see here. So it's like pretty good model. You can use it if you are having any kinds of object detection tasks. So you can use this particular YOLOv5 model, okay, on top of that. So most of the tasks actually it can solve very easily. So guys, now let's try to see how we can set up this particular YOLOv5 and how we can perform object detection with that actually. So for this, I already prepared one Colab notebook for you. So let me show you this particular Colab notebook. Yeah. So all the steps actually I have mentioned here. So I will share this particular code in the resources section. So there actually you can download this particular file and you can execute from your end. So if you want to use this particular YOLOv5, and if you see here, YOLOv5 is the research from Alternalytics. So this is the organization, they have proposed this particular model. And this is not just a model, actually, they have also created one framework. Okay, they use the same name called YOLOv5. And this is the official repository of this particular YOLOv5. So what you have to do, first of all, you have to clone this particular repository. Then after that, you have to install the requirements actually they have shared with you. Okay, so this is the requirements actually. So these are the library and tool actually you have to install. Then you will be utilizing this particular YOLOv5 in your system. So first of all, what I have to do, I have to open up one Colab notebook, which I have already opened. Now here you just need to select the GPU as a runtime. So let me select the GPU as a runtime. So I'll just click on the change runtime type. And here just try to select the T4 GPU. If you are using free Colab, so by default you will get this particular GPU. But if you are also using Colab Pro or any other Colab subscription, so you can get A100 GPU and V100 GPU as well as the T4 GPU. L4 GPU. So here I'm using free Colab. That's why I'm going to use this particular T4 GPU. Now I'll be saving this particular T4 GPU. And here I'll connect my notebook. So guys, as you can see, my Colab notebook has connected. And here I got the virtual RAM and virtual disk and virtual GPU as well. Now what I have to do, first of all, I have to clone this particular official repository of the YOLOv5. And if you want to clone, so this is the command git clone. And now you just need to get the link of this particular repository. So just click on the code and copy the link address and just try to mention it here. So I already mentioned. Now after that, actually I'm redirecting to this particular folder called YOLOv5. Okay, now let me show you. So if I clone this particular repository. So guys, my repository has been cloned. Now if I refresh, see guys, this is the YOLOv5 repository I have cloned. Now with the help of this particular cd command, cd means change directory, I'm going inside this particular YOLOv5 directory. Now if I just show you my present working directory, if you see, I'm inside YOLOv5 folder only. Now inside YOLOv5, I'm having this particular file called requirement.txt. Okay, this particular file actually I need to install. Now if I want to install this particular file, so I have to execute this particular command called pip install -qr requirement.txt. So it will install that particular requirements in a quiet mode. Then after that, I'm just importing the torch library and I'm just checking the version of the torch and all, right? So let me install and show you. If the installation is successful, that means everything will work. And if you're facing any kinds of issue, so definitely you have to fix that one. But I believe you won't be getting any kinds of error because I already checked this particular notebook and it is working fine for me. And I hope it will also work fine for you if you're following me so far. So let's wait guys. So I'll come back once this installation is completed. Then I will show you the import statement. So guys, as you can see, my installation is completed and here is the torch version I got and the CUDA version I also got, which is nothing but 12.1. So you can check this particular version. Let's say whenever you were setting these things in your local machine, that time you have to take care of this particular version. So make sure you have CUDA 12.1 in your system. Okay, otherwise it will get some issue. So guys, it is installed successfully. Now what I have to do, I have to prepare my custom data. So custom data wise, actually, I'm going to use here sign language data. I think you already know what is sign language. Sign language is nothing but it's just a sign. Okay, sign of a language. Let's say there are some dumb people. They can't talk and they can express their actually language. So what they use actually, they use this kinds of sign activity. Let's say if they're doing like that, that means they're trying to say hello. If they're doing like that, that means they're trying to say thanks. Okay, so this is the sign language actually activity. So here I already have some sign language data with me. So let me show you the sign language data. So guys, this is the data I already prepared. I'll show you how we can prepare this particular data and where you actually will get these kinds of image actually. So this image actually I collected with my web camera. So you can open up your web camera and you can click this particular image. Okay, let's say you just try to show the activity of the sign language and you just capture this particular image. With the help of OpenCV also you can write lots of automatic script, like if you just open up your camera and it will automatically capture your image and you just need to show the move. So that's how actually I collected some of the image. So in the training folder I am having 120 example, but whenever you are doing your actual training, so make sure you have lots of image here. Okay, just to show you the training demo I just kept 120 example, but make sure whenever you are training your actual model you are increasing this particular image size. Now here if you see guys, I'm having different image. So this is called actually please. So if you do like that, that means you are trying to say please. So here I'm having 6 level. So you can see please, thanks, then I'm having no, then hello, I love you, then yes. Okay, I think yes is also there somewhere. Yes is also there. Let me show you. Yeah, so you can see yes is also there. So now let me show you all the label one by one. So this is nothing but this is thanks. So if you do like that, that means you are trying to say thanks. And if you do like that, that means you are trying to say yes. So this is the American sign language, but if you are doing for the India or any other country, there this activity will change. Okay, you can search about this particular sign language on Google. Let's say Indian sign language. Okay, if I search for Indian sign language, you will see Indian sign language gesture would be a little bit different apart from your American one. See, so you are having lots of sign language. So you can visit website, you can visit different link and you can try to learn how to express for the Indian sign language. But here I'm going to use this particular American sign language. Okay, so this is the American sign language. Okay, and here I collected only 6 level. Now you can see this is the yes and this is the please. So if you do like that, that means you are trying to say please. And if you want to say thanks, so you have to show like that, that means thanks. And if you want to say, let's say no, so you just need to do like that, that means no. And there is another one called hello. Okay, as you can see. Okay, I think I forget to show you the I love you one. See, if you want to tell I love you, so you can show like that. And the last one is the hello one. So here is the hello. Okay, it's like very simple. So this 6 label actually I collected with the help of my web camera. You can also collect with your web camera. Okay, it's like very easy to collect. Now you can also get the data from different website as well. So you can also visit something called kaggle.com, Kaggle dataset. Okay, Kaggle dataset is also having lots of sign language data. So here you can search about sign language. Okay, image. See guys, you are having lots of sign language, as you can see, lots of sign language data. Now you can download any kinds of sign language data and you can use it in your project. Apart from that, you can also use something called Roboflow Universe. So you just need to visit this particular website called roboflow.com. So Roboflow is a computer vision platform. So here you can perform all kinds of job inside computer vision. So for the data annotation purpose, I'm going to use this particular Roboflow website. Okay, I'll tell you how we can use this particular Roboflow for the data annotation part. So make sure you have one account. So I already have a one account. So I'll just try to log in with my account. So you can create the account with the help of Google account. So it will take only 1 minute to create your account. So please try to create the account. I'm not going to show you like how to create the account because this is like very easy. Then here you will see something called universe option. Just go to the universe, and in the universe actually you are having, see, that much of data set. Okay, that many of data set. Okay, so now you can search any kinds of data set. Now let's say you want to do sign language, so you can search for sign language data, and here is the search button. So you will see different sign language data will come. See guys, different sign language data will come. Now you can also directly download this particular data. So now let's say I want to use this particular data. I'll click on this particular data. Now here if you see, one option called download dataset, just click on the download dataset option. Now here you have to download as a zip file and just try to select the format. So here you have to select YOLOv v5 because here we are using YOLOv v5 model. So here is the YOLOv v5 PyTorch. So you have to select this particular option and you just need to click on the continue button. So it will start downloading. It will automatically zip everything and it will start downloading. See, it has started downloading. That's how you can also get the data from this particular Roboflow universe. So not only sign language data, if you want to do any kinds of thing, any kinds of projects, all kinds of data are available. Let's say I'll show you. Let's say you want to do card detection, then player detection. Okay, then painting detection, card detection. Okay, then you are having also, let's say, people detection, all kinds of, see, industry safety detection, all kinds of data are available. Just search over any kinds of data. If you're looking for, just try to search over Roboflow universe, or else you can also search over this particular Kaggle website. So here actually most of the data you will get, and if you're not getting the data, that time you have to collect your own data. But collecting data is very much costly task. So for this you need time, you need lots of like manpower. But first of all, I will suggest whatever project actually you are doing, try to find the dataset over the internet. So that's actually you can get the data, guys. So I already show you my dataset. This is my dataset, and I already done the annotation. See, these are the annotation file. These are the txt file, because these are the annotation file. I'll show you how to generate this particular annotation file. But before that, first of all, let me show you why this annotation is really required for the object detection. So for this, I'm going to open up my Blackboard, and here let me show you one demo. So let's say here you have one image. So this is one image. In this particular image, let's say you are having one cat image, and you just want to detect this particular cat. Let's say this is one cat. I'm not good at drawing, so just try to consider this is a cat. And let's say there is a person also. There is a person in this particular image. So what you have to do for with the help of object detection, you have to detect this particular object. So let's say this is a cat. This is a cat. Okay, and this is a person. This is a person. So how your model will locate that particular object? Initially, let's say you will having lots of data. Like initially you will be having lots of images. Now here you are using one model called YOLOv5. Okay, YOLOv5. This is the model. So during training, what you have to do, you have to feed this dataset definitely to the model. But how your model will identify, okay, whether it's a cat, whether it's a person? For this annotation is required. Annotation. You can also talk about labeling. Let me write down labeling. Okay. So what is annotation and labeling? I think you know. So I think you know about supervised learning. In supervised learning, what we used to feed in the model, we used to give the X data as well as the Y data. So X data is nothing but my independent variable. Y data is nothing but my dependent variable, or we can also talk it as label. Okay. So I also need to prepare the label of this particular image file. So how to prepare the label? Let's say here I'm having one cat. Here I'm having one cat. So let's say this is the cat. So first of all, I need to annotate this particular cat as a cat. Let's say I'll create a bounding box and I will define as a cat. Okay, this is a cat. Now let's say here I'm having one person. I'm having one person. I'll also annotate this particular image as a person. Okay, that means I'll create a bounding box. I'll just name it as a person. Then it will generate one annotation file. That annotation file is nothing but it's a txt file. It's a txt file. I already showed you, I think. Now this is the txt file. If you see in the training folder, I'm having the image. With respect to the every image, I'm having the txt file. That means the annotation file. That means the label file. Now, if I open this particular txt file, you will see some information is there related our data. Now you can see here you will get some of the coordinate point with the label. See guys, here you are getting some coordinate point. That means this particular 4 coordinate point. Let me show you. So these 4 coordinate point actually you are getting. So this 4 coordinate point you are getting here. So 1 coordinate, 2 coordinate, 3 and 4. So this 4 coordinate, that means the actual label location. Okay, you are getting the actual label location. So let me open this particular file again. So here you can see you are getting that particular actual object location and the object label. Okay, that means the object name in a numerical representation. So here 5 means it is just defining as a 5. I think you have heard of something called label encoding. Let's say you are having 6 different objects. Okay, let's say you are having hello, then yes, there's no, then I love you. Okay, then please and thanks. Okay, 6 different label you are having. Now you have to define the integer encoding. That means the label encoding for each of the label here. So let's say hello would be assigned as 0, yes would be assigned as 2, no would be assigned as 2, and I love you would be assigned as 3, please would be assigned as 4, and thanks would be assigned as 5. So that's actually a label encoder happens. So you can see here it is assigned with 5 here. It is assigned with 5. Now what exactly this 5 is? So if you want to know about the 5, like what 5 is representing, so you can open up your data again, and there is one file actually will get called data.yaml file. Now let me open this particular data.yaml file. I'll open it with the help of Notepad++. So here you will see that particular label name, actual label name. So see guys, this is the list of the label I'm having, 6 label. You can see NC, that means number of classes is equal to 6. And now we just count 0, 1, 2, 3, 4, 5. That means 5 means, okay, 5 means it is yes. Okay, you can see it is 5. That means it is yes. It is trying to say yes location. Okay, yes location. That means yes coordinate point. Okay, yes coordinate point, yes location. Now with respect to that, if you are getting 0, that means it's a hello. If it is 1, that means it's a I love you. If it is 2, that means it's a no, and so on. And this is the image directory location. If you see here, this is the image directory location. So inside training folder, I'm having the image. Inside image, I'm having all the images. Same I'm having for the, let me show you. Same I'm having for the validation as well. So this is the folder structure. Okay, this is the folder structure for the YOLOv 5 you have to prepare. So this is the folder structure. Now for the testing also, I'm having the same format. Now you can ask me how to generate this particular folder structure automatically and how to generate this particular data.yaml file. So no need to worry, I will show you the annotation part. Once annotation is clear, you can easily generate this particular folder structure and this particular file with the help of Roboflow platform. Now, first of all, what you have to do, I already told you, first of all, you have to collect your data. Okay, first of all, you have to collect your data. Let's say you have collected your data and your data set is ready. Now, what you have to do, you have to upload this particular data to the Roboflow platform. Let's say these are my data I have collected. Just assume these are the data I have collected. So here you can keep your actual data, like all the data you have collected. But just to show you, I kept these are the example only. Okay. Now what you have to do, you have to logging up with this particular Roboflow platform. So I already showed you how to log in with this particular Roboflow platform. So once you log in, you will see this kinds of interface. So guys, if you open up this particular website, initially you won't be getting anything. Previously I did some project, that's why this project is coming here. So let me delete this particular project because previously I did one experiment here with the help of this particular data. So I'll delete this particular project, then I will show you. Okay, I will again upload this particular data here. Now I think sign language data is not there. Let me check. Yeah, it's not there. So first of all, what you have to do, you have to create one project here. So click on the button, create project. And here you just need to give the name of the project. Let's say this is YOLOv5 demo. You can give any name. You can give your project name. It's completely fine. Then you have to give the annotation group name. Okay, annotation group name means how many annotation group you are having. That means how many level you are having. So here I'm having different level. Yes, I love you. Okay, no, yes, please, thanks. So here I'm having 6 level. So all the 6 name you don't need to give. You can give only one name. Later on you can create. Let's say I will only give the hello here. Okay, hello here. Then here you have to select the project type. What kinds of project actually we are trying to do here. So here I'm doing object detection. If you're doing classification, instance segmentation, key point detection, you can select it. So going forward, we'll be also learning the instance segmentation, how we can perform the instance segmentation and all. But as of now, I'll be selecting this particular object detection. Now I'll just create this particular project. Now here, you just need to upload your data. So here is my data, guys. So what you have to do, just press Ctrl A, select all the data and just try to drag and drop here. So here I'm having 30 images, but whenever you are collecting your actual images, so it would be more than 30 images. Just to show you, I'm just keeping 30 images here. Now here, you just need to click on save and continue. So it will upload all the data in the Roboflow platform. Then you can start annotating on top of this particular data. Now see guys, you are getting some of the option. So just try to select this particular option, manual labeling. I'll start the manual labeling. And here I will assign the image. Okay, there is a button you can see. Okay, now here you will get the final button called start annotation. So I'll start the annotation. Now see guys, this is the annotation tool actually will get. Now you have to select the part of the object you want to detect. Now here I only want to detect this particular part, that means this particular hand part. Now what I have to do, right hand side you can see different options. So you have to select this particular option called bounding box tool. Just select this particular option and try to create one bounding box in a good way. Okay, make sure you are completing this particular object. So the more good annotation you will be doing, the more good learning your model will be, right? So here this is nothing but hello. I'll save this and again I will go next. So this is also hello. So here make sure it is hello and save this again first. So this is hello again. I'll select this particular part. So that's how you have to complete for all the image. Okay, you have uploaded here. So this is also hello. So I'm doing quickly because I want to complete everything, but make sure you are doing in a good way. And that is why actually data annotation and data preparation is like very costly task inside computer vision. So you have to manually handle each and everything. Okay, but if you have the data, training model is very easy. I'll show you. It is just only plug and play kinds of things. You just need to upload your data in the notebook, feed the model, and you can easily train that particular object detection model. But preparing the data is like very like hard task here. So this is also done. Now see, this is I love you. So select again, and now make sure you are giving I love you here. Hello, you just need to write. Okay, sorry, I again need to select it. Yeah, so this is nothing but this is I love you. So I love, okay, I love you. So now save, enter. Now go to the next image. So this is also I love you. Then go to the next one. This is also I love you. So here you can consider any kinds of object you want to. Let's say if you want to detect car, that time you have to select the car and you just need to write the car in that particular label option. Let's say you want to do person detection, at the time just select the person and write the person. Let's say you want to do smartphone detection, just write select the smartphone and just write smartphone there. That's how you can use any kinds of data set here. Here I'm showing you with the help of sign language, but you can use any kinds of data and you can get the data from, these are the open source platform. Okay, I already showed you. Now this is also done. I will go to the next image. So this is also I love you. I'll do it quickly because it will take time. So this is now no. So here you just need to write no. Save. Go to the next one. This is also no. This is also no. This is also no. This is also no. So here I'm just generating the label. I'm generating my actual y variable, that means y data, that means my label data, because this is a supervised learning. First of all, I have to teach my model. This is called no, this is called yes, this is called I love you, and this is the location of that particular object. So later on, whenever I'm giving any kinds of test data, my model will be able to detect that particular part, right? So this is called annotation, data annotation part. Now this is a please. This is also please. This is also please. Please. And this is thanks. Now this is yes. This is also yes. This is also yes. Yes. So that's how you have to complete for all the image you are having in your folder. See, the last one I have done. Now if you see, I have completed 28 out of 28. Now I'll just go back and here you will see add 28 image to the dataset. I will click on this particular button. Now it will automatically perform 10 test split for you. Okay, you don't need to manually do it. Now I'll just click on add image. So this is the button you just need to click. Now just create a new version of your data. And now if you want to perform any processing, let's say you want to perform resizing operation and all, you can do it. Otherwise you can continue. I'll just do it continue. And if you want to perform data augmentation, you can also perform data augmentation. Augmentation means you can generate some more data, okay, with respect to your real-time data. So there are some augmentation technique are available. Let me show you the data augmentation. Data augmentation. So this is the data augmentation, guys. Let's say you are having one image. Let me show you one good example. I think I can take this particular example. Let's say this is the original image. So this particular image, actually you are rotating, you are cropping, okay, you are changing the contrast, color. So this is called data augmentation. You are referring the same image, but you are generating some variant of that particular same image. Okay, so this is called augmentation. So if you're having less data and if you want to generate some new data, you can perform the augmentation. So I'm not going to perform any augmentation. I'll just click on continue. Now I'll just create the version of the data. Now once it is done, I'll just export the data. I'll select this particular download as a zip file, and format wise I have to select the YOLOv V5 PyTorch because I'm going to use YOLOv V5. Now just click on continue. See, it has started downloading. Now download is complete. Now if I show you my data, I'll go to the download folder, and this is the data it has downloaded. Now let me unzip it and let me show you. The same folder structure actually will get. So this is my folder. Now guys, see, you can see the same folder structure. Now you can delete this two file, it's not required. This readme file, this is just some metadata of your Roboflow. You can also delete the validation one. You can use the test one, either you can use validation one. So there I kept the test one. You can also keep the test one. You can also keep the validation one. Let's delete that valid one. Okay. And now see, this is my training image. So inside image, I'm having the images. Okay. And inside this particular labels, I'm having all the txt file, the annotation file. Okay, my actual label. Now same for the testing image also, I'm having the same thing. So this is my image and this is my label, and this is that data.yaml file it has also created. Now let me open this particular data.yaml file. So this is the YAML file. Now we can remove this particular part, it's not required. Now see, this is the actual. Now I can also remove the validation part because validation image I'm not going to use. Okay. Now training image I will be using for the training purpose, and valid test image I'm going to use for the testing purpose, testing of my model. Number of classes 6, and these are my all the classes. Now guys, my data is ready, and I think you got to know how to format your data, how to prepare the data, how to perform the annotation and all. So if I open up my Blackboard right now, so this part actually I have already completed. So I already showed you what is YOLOv V5 setup. I already showed you, prepared the dataset, custom annotation. And now let's see how we can configure the model and how we can start the training, evaluation, testing on the single image, live object detection, and how to create a web application. So this part is remaining right now. So now let's go to the notebook. Okay, let's go to the notebook. So installation is already completed. Now here, first of all, you have to upload your data. So what you can do guys, you can just make a zip file of your folder. Let's say this is the data. You can make a zip file, and that particular zip file you can upload here directly. You can upload here directly. Let's say you can upload here. See, there is the upload option. You can directly upload here, and you can use it from here. And there is another way you can read the data. So what you have to do, you have to upload your data to your GitHub. So let me show you. So if you are uploading your data to the GitHub, that means you can read the data from the URL. So I already uploaded my data inside my GitHub. So let me show you. So if I open up my repository, now here I am having one repository called branching tutorial. Inside that I already uploaded my data. Sign language data. See, sign language data. So this data actually I have already uploaded. So how to upload the data? It's like very easy. So you just need to drag and drop. Let's say this is your zip file. This is your zip file. So you just need to drag and drop here. Any kinds of repo you can use, drag and drop, and see it is uploading. So once it is done, you just need to click on commit changes. It will automatically upload. So I already uploaded. I'll just go back, and this is the data I uploaded. Now I'll open it up. Now just right click on the view raw and just copy the link address, and this is the complete link of your data. Okay, this is the complete link of your data. Now if you click here, it will start downloading your data. See, it will start downloading your data, but I will cancel it. So what I will do, I'll copy this particular link, and here you just need to mention. So make sure you are giving your link. You can also use my link to download the data, but it will download my data. But if you're using your own data, you can upload inside your repository and collect this particular link. Okay. Otherwise, you can also directly upload here. Both you can do. So I'm going to use this particular code snippet. So here I uploaded my data, and I'm doing the unzip operation. Then after that, I'm just using my data set. Now let me show you. So if I just execute right now, first of all, I'm going inside content folder. Then I'm downloading the data. Now if you refresh, see, my data has been downloaded, and all the files and folder you can see. My training, okay, training, testing, and data.yaml, everything is visible here. See, inside that I'm having my image. So if you are reading from the URL, that means you don't need to upload the dataset again and again. So this is the convenience, right? But if you are having more dataset, like let's say more than 100 MB, that time actually you can't upload your dataset inside the GitHub. GitHub will give permission denied error, right? At that time you can directly upload inside Google Colab, and you can read from here. See, this is the data. Now I think you can see now data.yaml file is already there, right? So now what I have to do, I already downloaded my data. Now if you just perform cat operation on the particular data.yaml file, that means if you want to read any kinds of content of any file, you can perform cat operation. So this is the command for the Linux. So in Linux, actually, if I want to read something, any file contents, I can use the cat command. So if I just execute cat command, it will show you all the content inside data.yaml. Now if you see here, number of classes I'm having 6. But this particular model you can see here, it has trained with something called Coco dataset. Okay, Coco dataset. So what is Coco dataset? As you can see, they have trained with Coco dataset. Okay, what is Coco dataset? You can search about Coco dataset. So Coco is nothing but it's a benchmark dataset. Okay, it's a benchmark dataset for the object detection. So researcher has already trained this particular model with the help of Coco dataset, this particular benchmark dataset, and it is having 80 classes. This Coco data having 80 classes. 80 classes object it is having. But here I'm having only 6 classes. So here what I'm doing, I'm just taking the transfer learning approach. That means I will be taking the pre-trained model. Okay, pre-trained model. This model is already trained. Pre-trained YOLO model. Okay, YOLOv5 model. On top of that, I will train my custom data. That means these 6 classes. Okay, 6 classes I'll be training. Okay, so how to configure this particular model right now with my 6 classes? So for this is the code you have to execute. First of all, you have to extract the NC parameter, that means number of classes parameter. So as you can see, I'll open up this particular data.yaml file with the help of YAML loader. Now I'll extract this particular number of classes, which is nothing but 6. As you can see, it is 6. Now what I have to do, inside YOLOv5, so there is one folder you will get called model. Okay, let me show you. This is the model. Inside that, you are having all the model configuration. Let's say I'm using this particular model called YOLOv5 model. I'll open this particular configuration. You can see here NC is equal to 80. I already told you Coco is having 80 classes. So I have to change this particular parameter. With my actual parameter, which is nothing but 6. So how to change it? So first of all, you just need to copy all the content inside that. Just copy all the content. Make sure you have copied all the content. And here you just need to paste it. Here. As you can see, I have already pasted in this particular cell all the content. Now, before that, you just need to execute this particular magic cell. So this particular magic cell will automatically change the parameter in the cell itself, right? Now see guys, now NC is equal to, instead of giving 80, I have given my number of classes. Okay, this number of classes variable I'm getting, this particular variable I'm giving it here. Okay, now it will automatically change this particular NC parameter and will save this particular file as a custom underscore YOLOv5 s.yaml in the same folder. Now let me execute and show you. Now if I refresh, so instead of changing this particular file, it has created another copy of the file called custom underscore YOLOv5 s.yaml. Now if I open this particular file, you can see this parameter has been changed with the 6. So that's how I can do the model configuration change, right? Now you can use any of the model. If you're using N model, X model, you have to do the same thing. Only you just need to change this particular NC classes, right? Now my data is ready, guys. Everything is ready. Now what I have to do, I have to start the training. And if you want to start the training, this is the command you have to execute. There is a file called train.py inside YOLOv5. So as you can see, train.py is there. So all the code they have already written for you. So you don't need to write anything. You just need to execute this particular file and you just need to pass some of the argument. So that's why I personally love this particular YOLOv5. It's a plug and play kinds of package they have created. So by executing some of the command, you can easily train your model. Now I'm executing this particular file YOLOv5 train.py, giving the image resolution size. So you can see my image resolution. It's if I show you my image data, based on the image resolution, you have to pass this particular size. If I show you my properties, if I go to the detail, so this is the resolution of the image. You can see 640 and 480. So that's why I have given this particular size. Okay, 416. But if you are using HD image, that time you can give HD image resolution as well. Okay, but you can give this particular size. Batch size you can mention. I have given 16 because I'm using free Colab. If you are having good configuration machine, at the time you can increase this particular batch size. Number of epoch, as of now I only want to train 100 epoch, but 100 epoch is not enough for the training. Make sure at least you are training 500 epoch. Okay, just to get some good output. But just to show you, in this particular video, I'm just training 100 epoch. Okay. Now here you have to provide the data.yaml file location. This is the data.yaml file location, as you can see. data.yaml file location. This is the location. So it will automatically load this particular file and it will get to know where is my image is present, where is my annotation file is present. Okay. Then you have to give the model configuration. The model configuration you have changed. So inside my YOLOv5 inside models. So this is the configuration file. Custom YOLOv5 s.yaml. Now you have to also give the weight. That means which model you want to use. I want to use this particular model. This model YOLOv5 s. Just copy the name and give it here and try to mention .pt. .pt is the extension of the model. Okay. Now you have to give the output location. That means all the model actually it will train, all the artifact it will generate, everything it will generate in this particular folder only. Now I will start the training. See guys, my training has started. After some time you'll see the epoch and all. See guys, it has loaded the model and now you can see and now you can see guys, my epoch has started. So it is running 0 out of 100. And this is the class loss, box loss, everything you can see here, and MAP score. So let's wait. Once this training is completed, I will show you how we can evaluate the model. Okay. And inside YOLOv5 folder, you can see it has created one folder called runs. Inside runs, train, and this particular folder, it is saving each and everything, all the results, all the metric, even your training model as well. As you can see, it is saving everything. So let's wait guys. So I'll come back once this training is completed. Then I will show you how we can evaluate this particular model. So guys, as you can see, my training is completed and I already got all the classes MAP score and all. And I'll show you how to evaluate this particular model and all. So for this, I will be using one metric here. So now you can see in the runs folder, all the artifacts has been generated and this is my best model. That means this is my trained model. So this particular model I'll be utilizing for the prediction purpose. And you can see lots of results and batch images has been also saved here. Now let me plot one by one and let me show you what you have to check in the evaluation part. Now, if you want to launch TensorBoard and if you want to check all the losses and graph and everything, you can execute this particular cell. So it will open up the TensorBoard for you and it will show you each and everything. So see guys, this is the TensorBoard and see this is the F1 score. This is the precision curve. This is the, you can see precision curve. This is the recall curve. This is the confusion metric and this is the results. Okay. But it's not properly visible. So what you can do, I can show you another way you can check. Now you can also check the GPU you got or not. So here you got Tesla T4 GPU, it's fine. Now there is one image actually it has generated called result.png. Now let's plot this particular image. So this is the code for this and this is the location of that particular result.png. You can see it is available inside this particular folder, result.png. Okay, I'm plotting this particular file. Now you can see this is my complete metric. Okay, so by seeing that particular image, actually you can evaluate your model whether it's learning better or not. Now you can see as per my epoch is increasing, loss is also decreasing, every loss is decreasing. So as you can see, this 6 losses should be less as per the epoch is increasing. That means it should be go down, and this 4 metrics should be go up as per the epoch is increasing. As you can see, this is my MAP score. That means, as you can see, this is my MAP score. That means mean average precision, and this is my recall and precision. So you can see my model is learning good. Initially it was some zigzag issue because initially it happens, it will pick up some random data and all. But at the end, actually you will see it's learning better. Now you can increase the epoch size, you can increase the data size. You will see training would be pretty good. Now you can see the evaluation. That's how you can perform the evaluation. Now you can also print some of the batch images. See, this is your actual batch images. Okay. You can also see the ground truth. So these are some ground truth. Even if you see runtime, it has performed some of the augmentation technique. You can see. So it has changed the brightness, it has changed the contrast, it has changed the cropping operation and all. So YOLOv5 by default, it will perform some augmentation for you at the runtime. Now what I can do guys, I can show you the actual detection. Okay, on top of my test data I'm having. So here is my testing images guys. So these are my testing images. As you can see inside test image, I'm having all of my images. So now let's load our model. The model we have trained. So this model is available inside YOLOv5 models. Sorry, not inside model. It is inside runs. Then train and this folder, and this is the model. But okay, this is the base.pt. So this is the location I have given, base.pt. The same image size you have to give. and confidence score you can give 0.5, and source is equal to test image. Okay, as you can see, this is the test image location I'm giving. So here is my test image location. Okay, inside image I'm having all of my test image, and I'm running one file called detect.py. So it is available inside YOLOv5. So this is the file called detect.py. Again, every code is written inside detect.py. You don't need to write anything. It will automatically load. It will automatically perform detection for you. So now what I have to do, I have to execute this particular line. Now it will pick up all the images, testing image one by one. It will do the detection and it will save inside the runs folder. Let me show you. Okay, so detection is done. Now if you want to see the results, so what you can do is can go inside YOLOv5 folder, and inside runs folder, inside detect folder, it has created detect folder experiment, and see all the detection you can see. So this is hello. See, hello is detecting perfectly with the help of 90% confident it is hello. Now if I show you any other one, let's say I love you. So see, it has detected I love you with 81% confident. That means detection is fine, guys. I only trained 100 epoch, although my detection is pretty good. See, no, and please also. You can see this is please, 91% confident. Thanks. See, this is thanks. You can give also. You can also show you the image. Now this is for the yes. Okay, that means all the detection is working fine, and that's how actually you can do the image level prediction. You can also keep single image. You can also give multiple image. Okay, this is the image level prediction. So if you want to perform camera level prediction, so what you can do, first of all, you have to set up this particular project in your local machine. Then there actually we can do the camera level prediction. So for this, what you have to do, you have to download only your model. So try to go inside training folder, YOLOv5 results, wait, okay. So this particular model you have to download, base.pt. So click here and try to download this particular model. Okay, so this model I need to the real-time prediction, because see, Colab can't access my web camera. So I have to set up everything in my local machine. Okay, so let me show you guys how we can execute this particular model in our local machine and how we can do the real-time prediction. And I will also show you how you can create the web application. That means web interface. I already created the application. I will show you how it can be integrated. Okay, so let me show you. So guys, I already downloaded that particular model, and this is the application I already created for you. So here I have created all the user app and everything. So what you have to do, you just need to open this particular YOLOv5 folder, and inside that you just need to paste your model. The model you have downloaded, this base.pt. Okay, this model actually we have downloaded from the Colab notebook. So this is my trained model, and this is nothing but my YOLOv5 repository. Okay, I cloned here. So this particular repository I cloned here directly. I cloned this particular repository. Okay, I just copied the link, and here I just done the git clone operation. Either you can directly download and you can keep it here. Okay, and some of the extra folders and file I created, I'll show you what are the changes I have done here. But before that, I just need to set up this particular project in my local machine. Okay, so for this, I'm going to open up my terminal, and I will share this code with you in the resources section. So from there, actually, you can download and you can set up with me. Now here, first of all, I will open up my VS Code. Yeah, so this is the VS Code, and in the README file, I mentioned all the setup. Okay, I think I haven't mentioned. So what I will show you, I'll show you the setup one. So here is the, yeah. So here I will open up my terminal. So first of all, you have to create one conda environment here. So let me create an environment. So you can write this particular command. So conda create -n. You can name this particular name. So I'll give a sign. Okay. You can specify the Python version. So Python is equal to, you have to take 3.8 -y. So this is the command to create the environment. So let's create the environment. Then after that, I will set up everything. Okay, it's done. Now let's activate this particular environment. So this is the command you can execute. Now let me clear. Then after that, I have to set up this particular requirement.txt. So how I collected this requirement.txt, I just went inside this particular folder, and this is the requirement.txt. I just copied. Okay, all the requirements I copied and I mention it here. So let me show you. And I mentioned in this particular requirements. Okay, see here I mentioned everything. And apart from that, I also need some additional package. So I kept these are the additional package here. So I need Flask, because with the help of Flask actually I'm going to create the user app. Okay, user interface. You can see here I created one HTML file. So in this particular HTML file I designed everything, all the CSS and HTML code, and with the help of Flask actually I will render this particular HTML page. Okay, so I have to install these at the library. So what I will do, I'll open up my terminal and I will going to execute this particular command. So pip install requirement.txt. So it will take some time. Once the installation is completed, I will come back. So guys, as you can see, my installation is completed. Now I just need to execute my endpoint. So endpoint is nothing but this app.py I created, and here is the like app implementation. So here I'm using Flask. So if you already know about Flask, I think you know how to use it. So here I'm initializing the Flask. I written one class, client app class. So whatever user is giving input, that image actually I'm saving as input.jpg, and this is the home route. That means if you are launching this particular application, it will render this particular HTML page, okay, index.html. And if you are doing the prediction, you can do the prediction. So it will execute this particular command. It will load your model, okay, and it will do the single image prediction. And this is for the live prediction, okay, live prediction. So yeah, let me use my model base.pt. So here everything you just keep it as default, no need to change anything. Now let me execute and show you how this application will be running. So I'll open up my terminal. So here you just need to execute python app.py. See, your application is running. Now just open your Google tab. Here search for localhost port number 8080. Okay, so this is the URL you have to search, localhost clone port number 8080. And now you can see your application interface. So this is the web interface. Now you can upload any kinds of image and you can do the image level prediction. So let's upload one image here. So I will upload, let's say, one image. Let's say I'm going to upload this particular hello image. Now let's predict. You can also open the terminal and you can see the log. So see guys, detection is completed and you can see the detection right hand side. Okay, that's how you can use this particular user interface and you can like detect any kinds of image. Let's say I will upload the thanks one. So this is like very easy for the user who doesn't know about the coding and all. So they can use your interface to perform the detection. So this is one basics template I created. See, this is the thanks one. Now if you want to perform, let's say, a live prediction, okay, with your camera, so what you have to do, so here itself you just need to give /live, okay, /live, and just press enter. So it will open up your web camera and it will do the prediction. Let me show you. So only the change you have to do, that particular model you just need to keep inside the YOLOv5 folder. That's it. Okay, and everything you can keep it as same. You don't need to change anything. So after some times, actually, we'll see it will open up your camera. So guys, now you can see the detect. It has opened up my live camera, but it is detecting some see extra things. Actually, some extra detection is coming because I trained very less epochs, and in my training image, this kinds of background was not there. That's why it's doing some mistake. But if I show you my hand, if you see, it's detecting perfectly. Okay. Hello. Then this is I love you. You have to increase the epoch, then it will detect more actually. So see, I already trained one model actually around 300 epoch. That model, let me just try to run and let me show you. So if you're stopping the execution, so what you have to do, in the folder itself, it will create one runs folder. You have to remove this particular folder. First of all, this runs folder you have to remove. Then after that, let me open up my code. So there I kept my model. So this is nothing but my model underscore pt. So this model actually I trained 300 epoch, more than 300 epoch. So this model, let me just mention here in the live prediction. Okay. So instead of base.pt, I'm going to use my model.pt. This model actually I'm going to use. Now let me open up my terminal again and let me execute my app. It's running. So I'll go back. And here I'm going to search for my application. And here let's give the /live. So guys, you can see it has again opened up my camera, but still it is detecting some background because my training image was not like that. So if you want to get a robust model, at a time you have to collect these kinds of image also. Now if I show you, see, this is hello. Now this is I love you. Okay. So this is thanks. This is please. So yes guys, that's how actually you can do the live prediction, but you saw that some of the mistakes were there because I trained this particular like model with very less epochs, and I was using very less training training images, and it was only from like one background. But if you're collecting from multiple background, if you're training in a good way, you will see the very good prediction there. Okay, so that's how actually you can set up and you can test your application, and here you can give your model, that means base.pt. Let me change this particular name. And there actually I was showing my model, that's why I given this particular my model.pt. This is your model. Okay, so now you can train any kinds of model, you can test with this particular application, and this is the user interface I created. All the codes I have shared with you, just go ahead and try to check it out. It's like very easy implementation and all. Okay, so yes guys, I think I have covered all that agenda. So we have seen like how to configure the model training, evaluation, testing, live object detection, and web application part as well. And guys, so yes guys, this is the application building and this is the custom training of the YOLOv3. So going forward, we'll be also doing the deployment. We'll be doing the deployment as a CI/CD with different cloud platform. And this is all from this particular video. I hope you have learned about this particular YOLOv3 like training on top of your custom data, and how we can set up also in our local machine, and how we can do the real-time prediction, real-time detection on top of that, right? So yes guys, this is all from my end. So thank you so much guys for watching this video, and I will see you next time. Hello guys. So guys, this is going to be one amazing video. So here we'll be implementing one awesome project called license plate extraction with the help of YOLOv3 as well as the parallel OCR. That means we'll be detecting the license plate, then we'll be also extracting the license plate information. Okay, not only that, after extracting the information, I will also show you how we can store these are the information to the database. Okay, so here we'll be using database to store the information. So guys, this is going to be one amazing implementation, so make sure you watch this video till the end. So first of all, let me show you the steps actually. What are the steps we're gonna perform to implement the entire projects. And no need to worry, all the code, all the material would be given in the description. From there you can download. And I already created one template for this project, so you can use this template as it is if you want to implement these kinds of projects, okay, with the help of different kinds of data and all, right? So you can use my template as it is. So let me open up my Blackboard and let me show you the steps we're gonna perform. So guys, I think you already know what is license plate detection. So you can see guys, this is the high level architecture. That means we'll be using a camera. So if you want to deploy this project in the real time, what you can do, you can use these kinds of CCTV camera. Okay, with the help of CCTV camera, you can first of all collect the image. Okay, collect the image of the car. Then you can apply the object detection model on top of it. And object detection model, what it will do, it will try to detect the object. It will detect this license plate object. Okay, after that you have to pass this particular license plate, okay, this object, the detected object, to the OCR algorithm. Okay, OCR, that means optical character recognizer. Okay, so what this OCR will do, OCR will try to extract the information. Okay, extract the information which is available in the license plate. You can see, let's say after applying this OCR, this is my information I got. Okay, this information I got. Now this information, what I have to do guys, I have to store in the database. Okay, so this is the entire idea. So for this, these are the steps actually we'll be following. So first of all, here you can see, first of all we'll be detecting the license plate. Okay, we'll be first of all detecting the license plate with the help of YOLOv3 model. Okay, and I think you already know, so YOLOv3 is having some pre-trained model. So in the model view, if you open up the GitHub, you will see that it is having some let's say pre-trained model, and this pre-trained model doesn't have any kinds of license plate, okay, license plate data, okay, license plate knowledge it doesn't have. That means when they train this particular model, they use something called COCO data. Okay, COCO data, I think you know COCO is a benchmark data. So inside COCO data, license plate data is not available. So what do we have to do? We have to first of all fine tune this model. Okay, we have to first of all fine tune this model on top of our license plate data, car license plate data. Okay, then after that we'll be getting one model. The model is base.pt, I think you know. So after training any kinds of YOLO model, what we get base.pt model. Okay, base.pt model. So this is going to be my trained model, and this model actually will be using for the detection task. Okay, so with the help of this model, we'll be detecting the license plate. Then we'll be recognize the text on the plates using parallel OCR. So here we'll be using Paddle OCR. So Paddle is a OCR, optical character recognition. So this is one of the amazing OCR, guys, and the accuracy is pretty good. So you can also use something called Easy OCR. Okay, Easy OCR you can also use. So in my YouTube channel, I created another tutorial related this Easy OCR. You can check it out. So that's why I took this Paddle OCR, because I want to also show you the Paddle OCR, and you will see the accuracy is pretty good. Okay, so we'll be using Paddle OCR to extract the information from the license plate itself. That means after detecting, I will get the license plate. Okay, here after getting detecting, we'll be getting the license plate, and this license plate I will be sending to the OCR algorithm. Okay, which is nothing but Paddle OCR. Paddle OCR will try to extract the information. Okay, then what we'll do, we'll save the accumulated unique license plate to a JSON file in every 20 seconds. That means after every 20 seconds, we'll be saving this particular, let's say, information to the JSON file. That means every 20 seconds, it will extract. Okay, it will extract the information from the license plate and it will save in a JSON file. Then every 20 seconds interval generates a new JSON file in a JSON file directory, and a cumulative JSON file is updated with a new interval data retaining previous entities without duplication. Okay, that means, see what I'm going to do here. Let me just simplify this particular term. So in every 20 seconds, my system will extract the license plate. Let's say it has extracted one license plate. So the license plate, let's say I'll name it as output 1.json. Okay, let's say this is my first file, and it will have one timestamp. Let's say the start time. Okay, start time, like what time it has extracted the, let's say this license plate, and then I will also let's say store the end time. So what is end time? End time means whenever 20 seconds would be done, so it will extract that particular time and it will save inside this particular JSON. That means my JSON will look like that: start time, end time, and the license plate. Okay, license plate data. Okay, that means whatever license plate, let's say, data it will extract, it will save inside that. So it will be a JSON format. Okay, JSON format. Then again, after 20 seconds, what will happen? It will again extract the information from the license plate, and again it will create another file called output 2.json. Okay, and inside that it will again store the information, the start time, end time, and the license plate. Okay, that's how after 20 seconds, okay, again after 20 seconds, it will again let's say save another file, again save another file. That's how if you are using video, based on the video frame, actually this execution will be running. If you are using the camera, that means whole day actually it will be tracking. You can also change the time. Let's say you want to do after 1 hour, let's say after 10 minutes, you can also change the time. It's up to you. So here I'm keeping 20 seconds because I want to show you as a demo. Okay, that's why. Then we'll be also creating something called cumulative file. And what is cumulative file? See, I'll be creating another file which would be my main file. Okay, let's say my final.json. Okay, let's say this is my final file. So inside that, what I will do, we'll take all the information. Okay, let's say first of all I will let's say open the output.json, and whatever information I am having, I'll store inside this particular file. Okay, then output to JSON, I'll store inside this file. Now let's say if there is any duplicates, let's say inside output 1, output 2, inside output 3, the same license plate it is storing. What I will do, I'll be only taking the unique, not the duplicates. Okay, that means I'll be only taking the unique. So this file will contain the unique, okay, unique plate information. That means this is going to be my final let's say file. So whatever, let's say, execution I'm doing, whatever file we are saving after 20 seconds, so at the end we'll be storing all the information inside one file, which is nothing but my cumulative JSON file. Okay, I hope you clear. Now after that, what we'll be doing, we'll be also saving. Okay, we'll be also saving this particular, let's say, information, whatever, let's say, final file you are getting, final.json, we'll be saving inside a database. And here we'll be using SQL database, SQLite database we'll be using, because it's easy to set up. It is already available in your system. If you're using Windows machine, if you're using any other machine, it is already available. So you don't need to set up it. Okay, manually you don't need to set up it. So in case, you can also use like MySQL data, you can also use MongoDB, any kinds of database you can use. It's up to you. Okay, only just you need to know how to set up the database. That's it. And this dataset is like very lightweight. Okay, that's why we'll be using this particular data. You are feel free to use any kinds of data, guys. Okay, so here I'm showing you with the help of SQLite, you can use any kinds of data. It's up to you. So first of all, let me show you the demo of the project. I think then this part would be clear. Okay, how actually it will save the information and all. and how your information will look like. I know that initially it would be a little bit like confusing for you to understand, okay, what I'm going to do, but after seeing the demo, you'll be able to understand, okay, what I'm trying to perform here. So see, first of all, what I have to do, guys, first of all, I have to train one YOLOv3 model on top of our car license plate data. So in this video, I already told you I'll be using one new state-of-the-art object detection model called YOLOv3, and this is like recently released model. And this is one of the amazing YOLO variant you will see. So this is the benchmark of YOLOv3. You can see YOLOv3 is performing better than your previous version of the YOLO. And it is like also good with the video. That means if you are if you want to do, let's say, real-time object detection. So if you want to perform real-time object detections, you can use this model. It is one of the amazing model because here you will get very low latency. And it is having different model variant. I will also show you like how many different model variant it is having. So this is the official paper of the YOLOv3. So if you are interested learning YOLOv3, like what kinds of architecture they're using, so you can deep dive in this particular paper. So I'll give the link in my description section. So from there, you can open this particular paper. Now let me show you the official implementation of the YOLOv3. So this is the GitHub, guys. And inside the GitHub, actually, you can see like they have given everything. Now here you can see the variant of the model. It is having different model like YOLOv3 N, then S, M, B, L, X. Okay, so these are the model variant it is having. N means this is the nano model, S means smallest model, M means medium model. Okay, that's how it is having a little bit bigger model. Now you can see the installation of YOLOv3. I will show you the easiest way you can follow to install this YOLOv3, okay, in your Google Colab. So here we'll be using Google Colab to implement the entire project. So let me show you guys. I already prepared one Colab notebook for you. So the first thing what you have to do, just connect with the runtime. So that means I want to connect with my GPU. So I already connected with my GPU. Now let me connect my notebook. This notebook would be available in the description section. So from there you can launch up and you can start the coding with me. So in between, let me show you the dataset actually we'll be using here. So guys, the dataset actually I'm using here, I downloaded from Roboflow. So let me show you. So there is a website you can always refer if you want to get any kinds of data or any kinds of computer vision related help. You can go to this particular website called Roboflow Universe. So inside Roboflow Universe, you will get all kinds of data related computer vision. It can be object detection, it can be image segmentation, it can be classification. All kinds of data is available. So this is the universe. Okay, universe means here you will get the data. Okay, all kinds of data, and you see the count of the data. Okay, now there is another website, Roboflow official, like roboflow.com. So here you can create an account, and in this particular platform you can do the annotation of your data. Even you can also train your model. Okay, even you can also deploy your model. Everything is possible here. Now, as I already told you, I'll be using one dataset called a license plate dataset. So you can see if I search this dataset here. So if you search anything in that search bar, you will get all kinds of data. Now see, you will have different license plate data. Okay, now you can download any of them. Let's say I want to download this one. So I'll just click here. So now you'll see one button called download project. Just click here. Now here you will get one option called download this dataset. Just try to click on the dataset. And here you have to select the format of YOLOv9. Okay, because YOLOv9 and V10 format are same. So you don't need to worry about, just select the YOLOv9 and try to download as a zip file. Either you can also download as a code, but I will be downloading as a zip file. Now if I click on continue, so it will download this dataset in my system and it will be a zip file. Okay, and your zip file, what other things would be available? Let me show you. So guys, you will get this kinds of zip file. Now if I open this zip file, so inside that you will have three kinds of folder: test, train, and valid. Inside that you will be having the images. So let me show you. So this is the images. Okay, this is the car images with the number plate, and you also have the annotation file, the txt annotation, because it's a YOLO format annotation. So here is the txt file. So it will have the label as well as the coordinate point of the license plate. Okay, so that's how actually in the all the folder actually you will have this particular data as well as the annotation file. And you will get another actually file called data.yaml. So let me open the data.yaml and let me show you. So this is the data.yaml, guys. Inside data.yaml, what you have to do, you have to mention the data location, like what is the image path. Okay, and number of classes. I am having only one classes. That's why I've given one. And the class name is license. Now, if you're having multiple classes, you can also mention here. Okay, it's up to you. I already explained so many times this thing. Okay, how we can create this data.yaml file. Fine. So now let me close. These are the file I don't need as of now. So I'll get back to my notebook. Now, first of all, let me check whether I got the GPU or not. So for this, you can execute this NVIDIA SMI command. And here I got the Tesla T4 GPU. Now, first of all, what I have to do, I have to clone the repository of the YOLOv3. So here, just open the repository, click on the code, copy the link address and try to paste here. Now see, if I execute this line, it will clone the repository in my Colab notebook. Now, first of all, I have to redirect to the folder. That means in this particular folder. So for this, I will be running the cd command. Now, if I show you my current working directory, I'm inside this YOLOv3 folder. Fine. Now, what I have to do, I have to install the packages, all the required packages. For this, you can execute this command pip install dot. So this dot will install all the required packages. Okay, you have here. So installation is done. Now, what you have to do, you have to download some of the model. Okay, download some of the model from the model zoo. And this is the link. Okay, this is the link for all the model. Now, if you want to download the model, just try to mention the link of the model. Okay, you will see this model is available inside this folder. Now here I've written a code snippet. It will download the model one by one from this particular URL. Now see, if I execute the program, so here I've added a for loop. So it will loop through this URL and it will download the model one by one with the help of request package. That's the idea. Now see, it will create a folder called weights. Now inside that it will download all the model. See, all the model, you can see it has downloaded. Fine. Now what I have to do, I have to upload my data. So what I can do, I can upload the data here. So let me upload. Just click on upload button. Make sure you're uploading inside YOLOv3 folder. Now I'll upload my data. So this is my zip file. I'm going to upload it here. So guys, as you can see, my data is down uploaded. Now if I refresh here, so license data is available here. Now I have to unzip this particular file. For this, just execute this command. Now see, my file has been unzipped. Now I can see my custom dataset. Okay. Now see, all the files and folders are available. See, all the folders are available. Now I also need to upload another file, I think you remember, which is nothing but my data.yml file. So let me also upload here. I'll upload. So this is my data.yml file. I'm going to upload it here. Again, I'm uploading inside YOLOv3 folder. Fine. All right. See, it is also uploaded. Now you can directly start the training for this. You can use this particular command. So let me train as of now 50 epochs, or I can train 100 epochs because I want to get a good model. And see, here you have to do, you have to run one command called YOLO. You have to give the task. That means you want to perform the detection. Then you have to give the mode. You want to do the training, okay? Custom training. That's why mode is equal to train. Epoch, I am training 100 epoch. Bash is equal to 16. You can decrease and increase based on your machine configuration. Plot true, that means it will create a runs folder. Inside that it will save all the artifacts, and here I have to specify the weights. So here I'm using YOLOv3 nano model, so it is available inside weight folder. I think you saw nano model. Okay, this model actually I'm using. You can also use any other model, okay, based on your requirement. Now here I'm passing the data.yml file path. Okay, so here is the my data.yml file path. Okay, because inside that I'm having all the location of my data. But one thing you have to change here. So you can see this is the actually current path, but I need to change the complete path. So what I will do, I'll just open. Inside that I'm going to change all the path. Now let's say inside training folder I'm having the image. I'll copy the path and here let me mention. That means you have to give the complete path. Okay, this is the complete path right now. Now for the validation as well, I also need to do the same thing. So I'll copy path and here let me mention it here. Okay. And as of now, I don't need the test image, so I'll just try to remove, because for the training, I only need training and validation image. Now let me close it. Everything is fine. Now I think I can start the training. So just click on the train. Okay, this one, it will start the training. So training may take some time, guys, because here we are using free Colab. So let's wait. Once this training is completed, we'll come back again and we'll try to test this particular model. So guys, as you can see, my training has started and epochs is going on, and per epochs you can see the losses as well as the MAP score. So let's wait. Once this training is completed, I will come back. So guys, as you can see, my training is completed and it has saved all the artifacts inside this runs folder. So let me open the runs. Inside detect, I'm having this training. Now inside that you will see all the artifacts, that means all the matrices. Now if you want to see them, you can open this result.png and you can see the performance of the model. So this is the complete results. So you can see losses is decreasing as per your epochs is increasing, and here your MAP is increasing as per your epoch is increasing. That means your model is learning better. You can see there is no zigzag, it is learning better. Now what I can do, I will just check whether this particular model is performing on top of my test data or not. So for this, I will do the inference operation. Now inside that, I'm going to upload one image first of all. So see, model would be available inside bird folder. So this is the model. Base.pt is my model. Okay, this is my trained model. Now inside this YOLOv3 folder, I'm going to upload one testing image. So I'm having the test image here. So let's upload this image. I think it is card.jpg. Okay, so this is the card and it is having one license plate. Now let's try to see whether it is able to detect or not. So to detect, you just need to perform this command. YOLO task is equal to detect, you want to detect, and mode is equal to predict right now because you want to only do the prediction. Confidence score, as of now I've given 0.25. You can also increase and decrease as per your requirement. Save is equal to true, that means it will save that particular let's say result, and you have to give the model location. Now model is available inside my runs folder. I already showed you now. Runs, detect, train. Okay, so it should be train, not train 2, because previously I did multiple experiment, that's why. Now this is my base.pt model and source image my card.jpg. Okay, so here is my card.jpg. Now if I execute the program, it should detect that particular license. Let's see. We can also do the same thing on top of the video. I will also show you how we can do on top of the video. Now see, detection is done. Now if I show you my runs folder right now, it has created another folder called detect. You can see detect, predict, and inside predict I have my prediction. Now see, card.jpg. Now if I show you the prediction, see, beautifully it has detected the license plate with the confidence score of 0.990. That means 90% it is confident it's a license plate. That means amazing detection, guys. Although you have used nano model and trained 100 epochs, but still the prediction is pretty good. Okay, now let's try on top of the video. So what I'll show, I will upload one video here inside the YOLOv3 folder. I'm having one video. So video is available here. So this is the video. So let me show you the video once. So here's the video, guys. So some cards are moving here. So we'll just try to apply the model on top of this video and let's see whether it is able to detect or not. And let's see the performance of the model. Okay, how it is able to detect in real time. Now I think it has uploaded. Now let me check video MP4 uploaded. Yeah. Now to perform on top of the video, this is the command you have to execute. The same command, only you just need to give the video location here. Source is equal to video.mp4. Okay, that's it. Now let me execute. And if you want to perform on top of the camera, source is equal to 0 you have to give. It will access your camera. And you have to set up everything in your local machine. So as of now, we are running everything on our Google Colab. So that's why it won't be able to access our camera. But if you want to perform on top of the camera, just give 0 here after setting everything in your local machine. Okay, this is the idea only. So now see, it has done on top of the video as well. Let me refresh. Let me show you. Let's inside detect, predict 2. And here is the video file. Let me download and let me show you. So guys, as you can see, my video is downloaded. Now let me open it up and let me show you the detection. See, amazing detection, guys. You can see real time it is detecting the license plate. Okay, these cars are moving actually. So same thing you can also perform with your web camera. As I already told you, only you just need to give the source is equal to 0. Okay, that means your camera location and everything you have to set up in your local machine. That's it. Now let's try to do the coding. That means we'll be creating the project. For this, what I've done, guys, I've created one amazing project template for you. So if you want to perform these kinds of project, so you can use this particular template as it is. So please try to start the repository. Try to also fork it. So that you will be having, okay, in your let's say account. Now what I'll do, I'll just try to clone the repository. So here I already given all the step how you can set up this repository. Okay, what are the command you have to execute? See, all the command I have already mentioned. So guys, the first thing we have to clone this repository. So let me copy the URL. So make sure you are clicking on the code, copy the URL, open up the folder, and you can open up your git bash. So this is my git bash. So here I'll write one command called git clone and I will paste the link. See, it is cloning my repository. So guys, as you can see, we have cloned the repository. Now what I will do, I will open it up, and inside that I'm going to open up my Visual Code Studio. So this is my Visual Code Studio. So here the next is you just need to create one virtual environment. Okay, so with the help of Python 3.11, you have to create one virtual environment. Just try to copy and try to execute from the terminal. So it will create a virtual environment for you. So for me, I already created. I'll just try to activate it. So this is the command. So you can see I've activated. Now the next thing, you have to clone the YOLOv3 repository because I think you remember we already trained this model with the help of YOLOv3. Yes or no? And after like training the model, we need to also download the model. That means our base.pt. And where you will get the base.pt, inside runs folder, you will get that particular base.pt and you have to download the model. So for me, I already downloaded the model. Let me show you. So the model, so this model is available inside wait folder. You can see. So the model actually I trained, I already downloaded the model from the Google Colab. Then you have to keep inside this wait folder. Okay. Then if I want to use this model, so definitely I have to first of all set up this YOLOv3. Okay, YOLOv3, right, in my environment. So for this, what I have to do, guys, I have to clone the repository, and after cloning, I have to set up this requirement. So this is what actually we'll be doing. So here is the command. First of all, you have to clone the YOLOv3. So just try to copy paste the command and execute in your terminal. After that, you will see that it will automatically clone this YOLOv3 repository. See, the YOLOv3 repository we have cloned. Then we'll be setting the requirements. So how to set up the requirements? This is the command, guys. So first of all, you have to set up the requirements which is having inside my project folder. You can see requirement.txt. Let me show you. So here is the requirement, guys. So this is the requirement. So these are the requirement actually you have to install. So you have to install Hugging Face App, Paddle OCR, Paddle, and DB SQLite. Okay, so these are the packages you have to install. So first of all, execute this command. So copy this command and try to execute from here. For me, I already installed everything. Okay, it is telling could not find. Okay, so first of all, what I have to do, I have to go inside this folder, because I am inside the new folder. So I'll just write cd license plate. Now see, I'm inside this folder. Now I'll clear. Then I will execute this requirement file. See, now for me, it is already satisfied because I already installed. But for you, it will take some time and you have to complete the installation. Okay. After that, you have to go inside YOLOv3 folder. That means there is a YOLOv3 folder. You have to go inside that. So open up your terminal. So this is the command. So copy this command and execute here. You'll see that I'm inside YOLOv3 folder. And inside that, you have to install all the requirements. So this is the command. So pip install -e space dot. Now just execute the command here. Okay. So let me copy. Okay. Now see, if I execute, it will install everything. Okay. For me, I already installed everything. Okay. That's why I don't need to do it. But for you, it will take some time. See, for me, it is telling requirement is already satisfied. Okay. Once it is done, again, you have to get back to your root folder. So for this is the command you have to execute. A cd space dot. Now you can see that I'm inside my root project directory. Okay. Then what we have to do, guys, we have to execute this sqldb.py. But before that, you may face some issue. So I was executing the project and I was getting some dependency issue. So how to fix the issue? So for this, you have to execute this two command. First of all, copy this command. First of all, you have to uninstall the NumPy. Okay, the latest NumPy, and then you have to install this particular NumPy. Okay, done. Now, once everything is completed, make sure, guys, you have executed all the command, whatever command I showed you step by step. Then you will be executing this sqldb.py. And if I open this sqldb, you can see it will create a database for me. Okay, it will create a database for me. You can see I'm connecting with the database. So this is the database it will create. And inside that, it will create some schema. You can see, first of all, it will create the start time, then end time, then the license plate information. And this is the data type. Okay. If you know about like database a little bit, I think you know, okay, what I'm trying to do. So first of all, let me create a database. So let me copy the command. So I'll copy and let me execute it here. See, I'll clear. And here I'll execute. So for me, I already created, first of all, try to delete. Okay. I'll try to delete everything. Inside JSON folder also, I'll try to delete everything because I already executed this project previously. Okay. So everything is fine. So now let me create the database. So guys, you can see my database is created, and I think you know SQLite is a local database. Okay. And I have already given you some data inside data folder. So some different kinds of video I have already given you. So you can use this video. So we'll be using these are the video to test our application. So this is one of the video. This is another video. And this is another video. So you can see cards are moving and we can see the license plate. Now we'll try to detect and extract the information and we'll be storing in the database. So I also given you some of the images. You can see some images also I have given you. All right. And inside notebook folder, I already provided the notebook. The notebook I showed you, the Colab notebook, so that you will have all the reference in one place. And in the wait folder, I have my base.pt model. Make sure, guys, you train your own model and you can keep it here. You can also use my model. I will also share with you my model. Okay, you can also use my model. Then you have to create a JSON folder. Okay, inside JSON folder, initially it would be empty. After executing my application, it will save all the information in a JSON format. So yes, these are the files and folder, guys. I think you got it. Now let me open it up. So my database is created. Now the next thing, I have to execute my main.py. So here is the command main.py. So let me execute the main.py. But before executing, let me explain what I have written inside main.py. So guys, you can see this is the main.py. So here I'm importing some necessary library. You can see I'm importing YOLOv3, NumPy, math. Okay, then datetime, paddle OCR. Then I'm also importing SQLite database. So I'm importing all the necessary library. Then I'm setting this environment variable, because if you're using paddle OCR, so sometimes you will get some warning and error. So to prevent this error, what you can do, guys, you can write this line of code. So if you go to the paddle documentation, you will see that they are also writing. Then with the help of OpenCV, I'm loading the video. So first of all, I'm loading this video. You can see, if I show you inside data, I'm loading this video. Okay, this is the video. Or what I can do, I can load this video. I think this video is a little bit bigger. And in this video, actually, like so many objects are available, like so many cards are available. So I can use this video. I think that would be fine. So instead of loading this video, I'll load this video, number 4, card license number 4. Then I'm loading the model. So the model actually I trained, it is available inside void folder. I'm loading the model. Okay. Then class name is license. I'm initializing the paddle OCR. And here I've created a function called paddle OCR. So this function will try to extract the information from the license plate. It will take the coordinate point. That means this coordinate point it will take. This 4 coordinate point it will take. Okay. So whenever you will perform the detection, after detecting, you will get the license plate coordinate. So this, license plate you have to pass, and how to pass with the help of coordinate point. And after that, it will extract the information. Okay. So this function will try to extract the information. Then after that, we'll be saving as JSON. So it will take the start timing, end timing, as well as the license plate information. Here I'm creating the dictionary. After that, I'm creating the timestamp like file and all. Then guys, you can see I'm creating this individual JSON file. So the things I have explained, I think you remember here. So first of all, after 20 seconds, it will create different JSON file. Okay. So this is what actually we're doing. Then after that, we're getting the cumulative JSON file. That means our final JSON files, which would be license plate data.json. Inside that, it will save all the unique license plate information. Okay. Now, once it is done, once we have saved the information to the JSON, then I'm saving inside SQL database. So this is the function I have written. Okay, save data to the SQL database. Now this is the function, guys. So it will take all the information and it will store the information to the database. And for this, first of all, you have to create the database. So we have already created a database. You can see. So this database we are loading and we're storing the information. And I will tell you how we can visualize the information inside database for this. Which tool you can use. We'll be using one online actually viewer, SQLite database viewer. With the help of that, we can see the information inside that. Then this is my final loop. Inside that, I'm performing all the thing. I'm loading my video frame. Then I'm loading the model. I'm doing the prediction, getting the bounding boxes. Then you can see I'm performing the paddle OCR. That means I'm extracting the information. After that, you can see here I'm saving the information. Okay, I'm saving the information as a JSON file as well as the database. So if you execute this function, it will save as a JSON file as well as the database. So guys, please try to open up this code in your code editor and try to go through this code, whatever things I have written step by step. And you don't need to remember this code, guys. This kinds of code is already available over the internet. You can copy paste from there. Only you just need to do some slight modification. The modification I have done, I created separate function. You can see I created separate function. And what I'm doing, I'm using all the function inside a one place only. Okay, I think you know how to read the frame, how to get the bounding boxes, okay, how to get the coordinate point. Then we already know how we can show this particular video in my window. So this is like basics of OpenCV. So previously, maybe you have learned OpenCV. So inside OpenCV also used to perform the same thing, right? So if you're already familiar with OpenCV, I think you already know what is happening inside this loop. That's it. And this template you can use as it is. If you're getting any kinds of project related that, you can use as it is. Okay, only you just need to change the data. Now, this is what actually we have written. Now, let me just test whether everything is working fine or not. So I have already deleted everything. Now I'll open up my terminal and Python main.py. Now see the things, guys. Okay, what I'm trying to say. So guys, you can see my execution has started and this is the window. Now you can see, guys, it is detecting as well as it is also extracting the license plate information. Now if I open the JSON folder, See, now if I open the JSON folder, now you can see guys, it is saving the information after 20 seconds. Now if I show you, see, first of all, it has created output, and this is the timestamp. It has saved the information. Now see, now inside this JSON, you can see start timing, end timing, and the license plate. Okay, the license plate information it has saved. Now again, after 20 seconds, after another 20 seconds, it will save another output. And this is the information. And this is my final JSON file. Inside that, you can see whatever information it has extracted inside output and output, let's say 1 and 2. All the information would be available inside only one file. Now you can see this information is available here also. Okay. Now see, after another 20 seconds, it will create another, let's say, output. And if you open the license plate, that means your final file, you will see that this information would be saved here. That means this is going to be my final file. And this will contain all the unique license plate, guys. Okay. You can see it is detecting. It is extracting the information. Now see. So guys, you can see my execution is completed because I was using the video. So video is having some certain frame. So frame is completed. And you can also use the camera. So if you want to use the camera, so what you have to do? So here you have to give the camera ID. Instead of loading the video, you have to. So if you want to use camera, so here you have to give the camera ID. I think you know how to load the camera inside OpenCV. So this line of code you have to only change. That's it. So guys, now you can see this is the final output I got. Now these are the information is also saved inside the database. Now I can't open the database. Okay, it's not possible inside VS Code. So for this, what we will be doing, we'll be using one amazing online viewer called SQLite viewer. So here is the link I have given in the GitHub. So now I'll just try to upload this file. So this is my database file. Try to upload it here. Now see guys, that's how your information will look like. Now this is the start timing, end timing. This is the information. This is the start timing, end time. This is the license plate. Okay. Start time, end time, license plate. Now you can see all the information it has saved. Now sometimes you can see it has also extracted some unnecessary information. It has also extracted some unnecessary symbol. But these are the things you can also filter out. And see here, Paddle OCR is a free OCR. And we know that if something is free, definitely you won't be getting 100% accuracy. Okay. And if you want to apply this project in the real world scenario, that means if you want to create a real world product, that time you'll be using more powerful OCR. You can use AWS OCR, you can use Azure OCR, some cloud-based OCR service you have to use that time. Got it? Now, I think you got it, guys. The entire idea how we can create this kinds of project. If I want to detect the license plate, if I want to extract the information, and if I want to save as a database, save inside a database, so how we can perform. Okay. Now all the resources would be available. Please try to clone and try to execute in your system. And if you're facing any kinds of error, you can let me know. So yes, guys, this is all from this video. I hope you like this video. So thank you so much for watching this video, and I will see you next time. So guys, here you can see I kept some example. So if you want to understand the object tracking, so first of all, try to see this image. So let's say in this image, actually, we're having some object, that means the person. So you can see it is first of all creating one bounding box. And what is this bounding box? I think you know this bounding box is nothing but it's a detection bounding box. Okay, it's a detection bounding box. That means first of all, you have to detect this particular object. It can be any kinds of object. It can be person, it can be cars, it can be, let's say, helmet, any kinds of object it can be. Okay. So first of all, you have to apply the object detection algorithm to detect that particular object. After detecting, you will be keep on tracking that particular object in each and every frame. Okay, that means, see, whenever I'm talking about video. So what is video? Video is nothing but it's a sequence of image frame. Okay, image frame, yes or no? Right. So you can see the image actually I have kept here. So this is a sequence of image. Okay, that means this is a frame. Okay, this is a frame of the video. So this is the first frame, this is the second frame, this is the third frame, and so on. All right. So what happens actually, let's say whenever we perform the object tracking, so it will keep on tracking that object in each and every frame. Let's say this is my first frame, and you can see we have done the detection. In the second frame, we'll be keep on tracking that object. You can see it is tracking. Okay, it is tracking the object. So everywhere you can see this particular bounding box. Okay, everywhere you can see this particular bounding box. And whenever you will apply the tracking, object tracking, you will see that it will generate one unique ID. Okay, unique ID. So this unique ID represents it is tracking the same object. Okay, let's say this is the person wearing a red jacket. So it will be assigned as 1. Let's say there is another person. That person will have another ID. So that's how inside the image actually how many objects you are having. Based on that, actually it will actually generate this kinds of unique ID. Okay, and with the help of this unique ID, it will keep on track that particular object. This is the idea of the object tracking. Now there is some issue. Okay, there is some issue with the object tracking. If we are using some traditional based, let's say, algorithm. So I think we know that inside object tracking, we are having some algorithm to perform the object tracking. Let's say we are having something called byte track. So previously I also created tutorial related byte track in my YouTube channel. You can check it out. Then there is another one called bot sort. So today I'll show you how we can use byte track as well as the bot sort. See, whenever I'm talking about bot sort, this is one amazing algorithm. It can also handle the hidden object. Let's say sometimes what will happen, let's say there are some objects you can see. Sometimes you will see that object will be disappeared, okay, inside a video frame, or let's say inside an image frame, and it will lose that particular ID. Let's say this person got ID number 1. After some times you will see that this person will disappear, okay, inside a, let's say, a video. That time your model will forget, and whenever this person will again come, it will generate a completely new ID. But it's not like that. If my model has given any ID to a specific object, it should remember. So let's say this person I have given the 1. So whenever it is disappearing from the frame, and whenever this person is again coming inside a frame, okay, it should remember. And if you want to achieve this kinds of accuracy, you have to use this bot sort algorithm. But bot sort algorithm is a little bit actually slower than the byte track. If you see the byte track is like a little bit faster. But inside byte track, actually these kinds of, let's say, a problem you can't solve. That means if any person is disappearing inside an image frame, it will completely forget that particular ID. Okay, it will generate a completely new ID if this person is again coming. Okay, so this is the idea. So both I will show you. You can use with respect to your requirement. Let's say you need a faster inference. Let's say you have one video, you have one condition there. You don't have any kinds of, let's say, hiding condition. Let's say there is a bottle filling system. So bottle will come sequentially. So there is no possibility your bottle will hide, right? That time you can apply byte track on top of it. But let's say you are applying on the pedestrian, or let's say cars, okay, let's say inside traffic. So that time you can use this bot sort one, because there is a possibility your object may actually hide. Okay, so that's actually you have to choose what kinds of algorithm you should use. So today I'll show you both of them. You can use any of them. Okay, and see, to perform this tracking, I'm going to use Alterytics because as I already told you, first of all, we have to perform the detection, and to perform the detection, we'll be using YOLOv3. And I already covered how we can use the YOLOv3, how we can perform the object detection with the help of YOLOv3. Even I already showed you the custom trading and all. So everything I have covered in my YouTube channel, you can check it out. Then after getting the detection, what I will do, guys, I'll pass this detection to the tracking algorithm. That means we'll be passing to the byte track as well as the bot sort. Then it will keep on tracking that particular object. Okay, so both will be showing. So for this, guys, what I've done, I have created one amazing notebook. You can see this is the notebook I have prepared. So first of all, I have to install the Alterytics package. Okay, because if I want to use the Alterytics YOLO functionality, or let's say tracking functionality, I have to install this particular package. So to install it, first of all, you have to connect your GPU. So here I have already connected my GPU. Now let me install. And all the resources should be given in the description. From there you can download and you can try with me. And how to perform the object detection, image segmentation, I already created one playlist called YOLOv3. So there I have covered each and everything. Okay, you can check it out. And if you want to download any kinds of computer vision related data, guys, what you can do, you can use one amazing website called roboflow.com. So Roboflow is a platform. It provides actually all kinds of computer vision related toolkits. So it is having one amazing product called Universe. So let me open it up. So inside Universe, actually it is having all kinds of data. So here you can download object detection, image classification, segmentation. Okay, all kinds of data are available. So here you can download any kinds of data set. Let's say in this case, actually what we are doing, where we'll be using actually pedestrian, pedestrian data. And I think you already know inside Coco data, already pedestrian, let's say data they have already trained with that model. So I don't need to again fine tune that model. Okay, so this object is already available inside Coco object. Okay, inside Coco classes. If you open the Coco class, you will see that pedestrian is already there, person class is already there. Okay, but in case actually, let's say you want to perform any other tracking, let's say you want to track hand, or let's say you want to track helmet, you want to track motorcycle, that time what you can do, guys, you can simply search here. Let's say I need card data. So here I will just search for card. See, all kinds of card data you will get here. So you can download the card data and simply you can train one object detection model. Okay, then after that you can perform the tracking operation. Okay, so this is the simple idea. Now see, guys, this is the data related card. So simply just try to click here. Let's say I want to download this data. So if you want to download this data, you just need to click on the button. Then you will be getting one option. You can either download as a zip file, either you can download with the help of code snippet. You can do it. So let's get back to our notebook, guys. So this is the notebook. So I've already installed the Alterytics. Now, first of all, we'll be applying the detection. So here I'm having one video. Let me show you. So guys, this is the video actually I'm having, and you can see there are so many objects, like a person is there, then you can see this wheelchair is there, then cars is there, different objects are available. First of all, let's try to see what are the objects my model can detect. So what I will do, guys, I will simply upload this image video here inside my Google Colab, and here you can see I'm using YOLOv3 model. So I'm using medium model, and you can get it from the Alterytics. And inside the model, you have to pass the video. The video actually you have uploaded. So just copy the path and try to paste it here. Now, if I execute, you'll see that it will first of all load the video. It will load all the frame one by one. It will perform the detection, and it will give you the results, okay, inside the runs folder. So you can see, guys, the detection has started. You can see we are having 188 frame, okay, in this video. So guys, as you can see, my execution is completed. Now if I open the runs folder, so guys, if I open the runs folder, inside that you can see detect folder, predict folder, and this is the results. Now let me download and let me show you. So this video is downloaded. Now let me play. So guys, you can see this is the results. Now you can see there are so many objects it is detecting. It is detecting the car, then you can see the wheelchair, then the person. Okay, so it is also detecting the suitcase. But I don't need actually all the objects. I only need the person. So in case actually what you can do, there is a one parameter you can set called classes 0. So if you open the Coco dataset, you will see that person class is present at the first position. That's why you're given 0. That means I only need the person classes, okay, not any other classes from this particular, let's say, image or video. So now if I execute, you will see that again it will perform the detection, but it will only detect the person, okay, not any other class. Because here we have specified I only need the person class, okay. So if you want to, let's say, detect any other object, please try to open up the Coco data, and you can see the location of the object. With respect to that, you can pass the ID. So now it's done. Now if I again refresh and let's download the video again. So guys, now if I play the video, you will see that it is only detecting the person, okay, not any other class. So that's how we can specify which actually, let's say, object you need. So now we are able to perform the detection. Now let's see the tracking, okay, how we can perform the tracking. So first of all, I'll show you the bot sort one. So if you want to use the bot sort, so you have to use this syntax. So just write model.track. Inside that, just try to pass your source image, source video. So this is the source video, and parse is true and save true. So you don't need to specify the bot sort algorithm separately. So by default, it will load it. Okay, now let's see if I execute. So execution is completed. Now just try to refresh and try to download the video again from the predict folder. So guys, you can see my video got downloaded. Now if I play, so this is the tracking. You can see it has created this ID, you can see, okay, and it is tracking this object, and the result is pretty good. If you have any, let's say, object which is, let's say, hiding in any other object, still it will be able to remember. So this is happening with the help of bot sort algorithm. Now guys, if you want to perform with the help of byte tracker, what you just need to do, you need to give this parameter tracker is equal to bytetrack.yaml. Okay, that's it. And that much easy it is. If you're using Alterytics, you don't need to do so many configuration. Okay, everything would be done as an automated way. So you can execute this byte track and you'll see the same output. You can download and you can see that. Okay, so yes guys, that's how we can perform the tracking with the help of YOLOv3 byte track as well as the bot sort algorithm. First of all, you have to apply the detection algorithm. Detection will detect, then that detection will pass to the tracker model, and tracker will track that particular object. Okay, this is the idea. So yes guys, this is all about. I hope you liked it. Thank you so much for watching this video, and I will see you next time.